Hello everyone, welcome to my presentation. Today I'll be talking about my project at Carnegie Mellon summer of 2021 with my advisors Daniel Hughes and Cassia Sicara. The project is multi-agent hierarchical reinforcement learning for search and rescue. A little bit of background, so in search and rescue, a team of AI agents need to navigate through the environment to locate and rescue victims. So here you can see there are three agents with different capabilities. The victims are colored in green, and some victims are buried under some rubble. The goal of the AI is to efficiently rescue as many victims as possible and in the shortest amount of time as possible. The way that we are going to achieve this is through reinforcement learning. So this is a schematic for reinforcement learning. In reinforcement learning, an agent or multiple agents who interact with the environment execute some actions and receive the reward for their actions and transition to a new state. So in our problem, a state might include the agent location, and the reward can be +1 whenever the agent successfully rescues a victim. So what reinforcement learning allows us to do is to train agents that behave optimally to maximize the reward. One sub-branch of reinforcement learning is hierarchical reinforcement learning. So here we have hierarchies, whether in the action hierarchies or in the state hierarchies. Hierarchical reinforcement learning allow us to more effectively plan in complex environments. So first, let's talk about hierarchies in actions. This is the option framework introduced by Sultan and others in 1999. The idea is that humans and other intelligent agents can decompose their actions into high-level quote-unquote options and low-level primitive actions. So for example, here you are trying to decide what to cook for dinner. The high-level options are cooking pasta, potatoes, or fried rice. Once you have chosen a high-level option, let's say you want to cook potato, then you can execute a sequence of primitive actions like boiling the water, chopping up potato, chopping up onions, etc. to accomplish your option of making a potato dish. As such, there is a division between the overarching goal of cooking dinner and a sub-goal of making potato dish. In our search and rescue task, there would be a coordinator who give high-level command to agents who execute primitive actions to achieve their assigned subtask. So this allows for coordination between agents and better performance because the coordinator would be able to delegate different subtasks to different agents to avoid some inefficiencies. So now let's talk about the state abstraction. So here there is a map of the environment. As you can see, the environment is divided into rooms and hallways, and from this we can build a graph representation of the environment where each node corresponds to a room. The coordinator would only keep track of which agent is in which room, aka which node in the graph. The coordinator doesn't care about the precise location of the agent within the room. This is more effective from a planning because it allows for specialization. The coordinator would focus on the big picture while the agents take care of the low-level mechanics. An application of this work in the far future would be robotic team, where the robotic team would carry out these search and rescue missions instead of humans, and this would avoid danger for the humans. Also, robots may be better than humans in some regard. For example, they do not have mental fatigue or mental stress. They do not experience memory loss. So they would, for example, they would remember where the victims are. and they also have no inefficiency caused by infrequent communication. Another direction would be interventions where the AI helps humans. So here we can have two frameworks, the agent advising framework. So in the agent advising, the AI predicts the human actions and intervenes whenever it believes that the humans are going to make mistake. And in active imitation, the AI observes the human action and provide feedback to correct the mistakes. So the AI would tell the human what they should have done. So this is the end of my video. Thank you for watching and have a wonderful day.